The sustainability of our world depends on nutrients and the way they cycle through the environment. Carbon, nitrogen and phosphorus cycles are all pivotal in providing food, timber, fibres and fuels. They regulate our climate, protect human health, and are an important driver of changes in biodiversity. Through industrialization, agricultural intensification and urbanization, we have altered these cycles. For example, the use of inorganic fertilizers containing nitrogen and phosphorus increases crop yield, but cropping diverts carbon away from the soil. And overuse of fertilizers can lead to enrichment of nitrogen and phosphorus, with knock-on effects for biodiversity and water quality. It is important we understand carbon, nitrogen and phosphorus cycles, so we can, in turn, understand the consequences of human interventions. However, these cycles are complex. They span the Earth, from the atmosphere through to plants, soils and water. And the cycling of the elements themselves are interlinked through biological processes. Living organisms need carbon, nitrogen and phosphorus in relatively fixed proportions. And so, life on Earth closely links the cycling of these three elements. For example, plants attain the carbon they need from the atmosphere via photosynthesis, but it is often the amount of nitrogen and phosphorus available in the soil that determines their growth. Nitrogen is abundant in the atmosphere, but most plants can't access this. They need bacteria that live in the soil to convert this atmospheric nitrogen to forms that plants can use. The ability of bacteria to do this is dependent upon the availability of phosphorus in the soil, which in turn comes from the weathering of rocks, weathering that can be accelerated by plant and fungi activity. And so the amount of carbon entering plants is regulated by the amount of nitrogen processed by bacteria, which is related to the amount of phosphorus. And this is just one set of processes that links these three elements. That is why, in the long-term large-scale macronutrient cycles project, we're developing computer models that link carbon, nitrogen and phosphorus cycles, linking scientific disciplines and linking people to improve our understanding of nutrient cycling change and its consequences, to help work towards a more sustainable future.